Alright, welcome back. We are going to continue on with our exponential rules. We have talked about the addition rule and the the division rule. Now we're going to talk about the power to power rule and then the negative exponent rule, which I talked about a little bit last time. So power to power rule, notice we have x raised to a power, and then the whole thing is also raised to another power. And when that happens, we simply just multiply the two exponents together. And with the negative exponent rule, I'm gonna explain this a little bit more in detail later. But what we do is if we have a negative exponent, we take the base and we place it under a fraction bar. And if it's already a fraction, then it would become up. And you could always put over 1. You don't have to though. But notice that the answer here is not turning negative. All it is changing the placement of my base. And like I said, we'll go more in depth to that because it's a little weird. And negative exponents typically give the most trouble when we combine all of these rules together. But let's go ahead and first look at the power to power rule. So power to power, I can make up a problem with numbers or letters. Let's do a number 3 to the third to the second. And so I have essentially what this is saying that I have 3 3s. And I'm going to write kind of the expanded way out first just to kind of give an idea so you can get an idea of what this means. It's very important when you go through rules like this to understand the meaning behind it. And if you can understand the meaning behind the rules, why do we multiply when it's power to power? Why do we add when it's multiplication? If we can understand the meaning of it, then the memorization is completely gone, and it just intuitively makes sense to what to do, and that's where you really got to get to. And the reason why people struggle with this is because they have to memorize the rules, and then they're given situations where there's a bunch of different rules that they have to apply, and it can get very tricky if you're trying to just simply look at these rules, because they don't always will look simple like this, like these simple cases. But we have to know the simple cases in order to get to the more complicated cases, and we'll probably get to the more complicated cases in my next video. So the concept here is that 3 to the 3 is saying that I'm raising 3 to the third power, which is 3 times 3 times 3. And so 3 times 3 times 3 to the second power, if we think about this as just being a single number, doubles what I have inside the parentheses. That's what the squared will do. And so I would get 3 times 3 times 3, and then 3 times 3 times 3. And then now we have all the 3's expanded. So how many 3's do I have? I have 6 of them. 3 to the 6. And so does our little rule work? M times n, 3 times 2 is 6. Now we could do a letter. I'm going to do a combination of a letter and a number. This is where people will run into problems with these. If I had, for example, 4x squared raised to the 4. So if I just look at the x squared, and again I could write the expanded form out all the way, but let's just go ahead and kind of do this one using our power rule. The x to the second seems like I would multiply the 2 and the 4, and that would be exactly correct. And so I'd get x to the 8. Now this 4 here, some people will either leave it off or just leave it as a 4. Sometimes most commonly is they end up multiplying these together, and you're probably going, well, isn't that what I'm supposed to do? I'm supposed to multiply them together? No. These these are exponents. The m and the n are exponents. This is the rule to dealing with exponents. This 4 here is not an exponent. It is a number. And if I have a number raised to 4, then that's exactly what I have to do. 4 raised to 4. And then multiply that out, which sometimes you do have to, sometimes you don't. Usually the general rule is if it's to the 4th power, you multiply it out, and if it's higher than the 4th power, then you don't. But it really depends. That doesn't look like a very good 8. And there we go. So there's power to power. Just be careful with numbers that are inside the power, and we'll do some ones with the negatives, and that can get really tricky as well. What happens to negative numbers inside here? But the general power rule applied here: 4 times 2, 8. And then, of course, the first one, 3 times 2, 6. So now let's look at negative exponents. So here's our rule for negative exponents. And let's go ahead and just do an example. I'm going to go ahead and change colors here. So let's do 6 to the negative 1, and what would that equal? Well, according to this, 6 is my base, and it gets placed on the bottom. And that's exactly what this is. This negative 1, that's obviously the first negative we'll run into integer-wise, and this negative 1 is, there's actually a button on the calculator that either looks like this, or it could also look like this. But what that means is the inverse. Take the inverse. And what's an inverse? Well, the inverse of 6 is simply the reciprocal of 6. And that's really the whole heart of what a negative exponent is. Negative exponent means reciprocal. That's very ugly, but in any case, so when we ask for the reciprocal, it's simply what number times it. What number would it be times to get 1? And so if I said 6 times 1, 6, that equals 1. And so that's how I confirm that I have a reciprocal. Also, the definition of inverse is this as well. So that's why this part over here is true. So if I had 1 over 6 raised to the negative 1, that would equal 6. Inverse of 1/6 is 6. So let's take a look at some more. In this case, let's do 3 to the negative 2. And so, well, there's a couple ways I can approach this. I can pretend the negative's not there. And what would 3 squared be? That'd be 9. And then it'd be negative, and then I would flip it. I don't like to do that. I like to go ahead and deal with the negative right away. And so I see that 3 is obviously a whole number. It's on top of a fraction. It could be 3 over 1 if I wanted to write that. And so I'm going to go ahead and now rewrite it where it's on the bottom of the fraction. And that takes care of the negative part. We haven't taken care of the 2. So that 2 is still there. And what is 3 squared? 9. Let's do something a little tricky. So here I have 2 numbers. The 4 is on top, and he has no exponent, nothing going on with him. On the bottom, we have the 2 to the negative 1. And so, again, where is this located? This is located on the bottom of the fraction bar. And so it's telling me, put this on top. Give me the reciprocal. And so I know that 2 is now on the top, and I could, put the 1 there, but obviously 2 to the 1 is just 2, so I don't have to do that. And now what do I do with this 4? This 4 was still here, and whenever we shift things up from the top and the bottom like that, it's simply just a multiplication. And what's now left on the bottom? Well, 1, which again, optional. Don't have to write that. And so now I just have 4 times 2, which is 8. Okay, let's do one where we have negatives on top and bottom. So if I had 3 to negative 3 over 2 to negative 3, what happens to this? Well, on top we have a negative number, or a negative exponent, which is again telling me reciprocal. Where is it going to go? It's going to go be on the bottom of my fraction. And then the bottom one has a negative, and so it's telling me put it on top. And so now that I have cleared all my negative, that I can just simply evaluate both of these. And so 2 to the third is 8, and 3 to the 3 is 27. Okay, one last one. This will be a mixture of dividing and negative exponents. So whenever we have a combination like 3 times x to the negative 2, we have to always remember what is being raised to this negative exponent. The 3, while it's right next to it, does not count. It is not being raised to the negative 2. Only the x is. If you think over operations, what happens before multiplication is the exponent happens first. So this x to the negative 2, it's the only thing that's being raised by a negative. And so that's the only thing I'm going to move. The 3, not going to move. 9, not going to move. And this x to the 4th, not going to move. So only this x to the negative 2 will move. And so we'll do that. And so now, what do I do? With this, well, I can just simply, this is my multiplication, so it's my addition rule. And then I'll take care of the numbers. So what do we do with this 3 over 9? Well, this is just if it was a simple division, 3 divided by 9, and this is a fraction, it'll reduce. Be careful not to get in the habit of using, the division rule, which subtracts the exponents. These are not exponents. These are just regular numbers that I need to simplify as 1 over 3. And then there we go. So next video we'll talk about all these kind of rules mixed together, and we can kind of see what it's going to look like. Here's a problem that we did that had a couple rules in it, and we'll just go ahead and do a bunch of practice with those. The trick with these exponent rules is to really practice getting working on these, getting these concepts clear and understand why things are happening. Now the negative exponent is not like an intuitive, like, oh, that makes sense, kind of thing. It's, here's a concept of what happens when we have a negative number in the exponent. This is what happens with it. It's a reciprocal, and it's just really a notation. So this is the one rule that's kind of weird, and the other ones, however, the two we did before and this power to power, if you think about the expanded forms like we did here, it kind of makes sense what's going on and why things are happening like that. So we'll practice this next video, and I'll see you then.